Hello and welcome back with Mrs. Struble. In this video, we're just going to spend a quick moment discussing compound probability and how you would calculate it. Okay? So what compound probability is it's essentially the probability of two or more events occurring. These events can be independent from each other or dependent from each other. We are going to focus on independent probability, where it doesn't matter what happens with the first event to get the second, okay? So how do we calculate compound probability? Now, the calculation of compound probability is fairly simple. We're going to take the number of favorable outcomes and divide it or put it over the number of total possible outcomes. We have to identify the total possible outcomes by using either the fundamental counting principle or a sample space. Let's take a look at an example. In this example, it says, what is the probability of rolling a number greater than 4 and flipping a tails? Okay, assuming the coin is fair. So we can make a sample space to help us answer this problem. Quick refresher on sample spaces. We're going to take the two events, rolling a number cube and flipping a coin, and identify all of our possible outcomes using this little table here. So the coin could be heads or it could be tails. When we roll a number cube, we could get 1, 2, 3, 4, 5, or 6. Okay. 1 heads, 2 heads. So we're really essentially just laying out all of the possible combinations of these two events. Okay. All right. Now going back to the problem, we need to identify what our favorable outcomes are. So what do we want to happen? We want to roll a number greater than 4, and we want to flip a tails. So we need to identify the outcomes that give us our desired outcome. So greater than 4 is going to be either 5 or 6. Doesn't matter, either one. And then tails, well, obviously we need to have tails. So these two outcomes satisfy our expectations of rolling greater than 4 and flipping a tails. So we get 2 out of how many total? Again, that's where that sample space comes in. We got 2, 4, 6, 8, 10, and 12 total possibilities. Okay, so our probability is 2/12 or 1/6, okay? Which means 1 out of every 6 times, theoretically, I should get a number greater than 4 and tails. Let's do another one. In this situation, we have a spinner and we're flipping a coin. And it's asking us to find the probability of each compound event. Number 7 says spinning a 3 and flipping heads. That's our desired probability. You might also see, you might also see the question looking a little bit like this. Okay. This is the shorthand version of asking you what the probability of spinning a 3 and flipping heads is. Okay? The comma in between shows you that this is a compound event. Okay, so that kind of gives you a heads up. This is two things happening. First, spinning a 3, then flipping a heads. Okay. All right, so the probability of spinning a 3 and flipping a heads. Well, let's see. Flipping a coin, we can either have heads or tails. So there's two possible outcomes here. We're going to use the fundamental counting principle to help us identify how many total outcomes we have. When I look at the spinner, there are 8 possible outcomes there. Spinning the spinner and flipping a coin is going to give us a total of 16 outcomes. So our denominator is going to be 16 in our probability. But how many of these will give us a 3 and heads? Well, that's very specific. 3 is 1 out of the 8. Okay, so the probability of spinning a 3 is 1 out of 8 spots on the spinner. The probability of spinning a heads, or flipping a heads rather, is 1 out of 2 sides of the coin. In fact, there's really only the one option. Okay? This is very specific. So our compound probability is 1/16. Let's do number 8. Spinning an odd number and flipping tails. Okay. So it's essentially asking us here what the probability is of an odd number and tails. Okay. Taking another look at the spinner, we identify 1, 3, 5, and 7. 4 of them are odd out of 8 total. Tails, well, again, we still only have 50% chance, or 1 out of every 2 times. Theoretically, we would get tails as probability. But together, combined, what would our probability be? There's still only 16 possible combinations when we're dealing with this spinner and the coin. Now that we added more options in the odds, okay, we could pick 3, or we could spin 3 and then get a tails, 5 and get a tails, 7 and get a tails, or 1 and get a tails. So there's 4 possible combinations out of 16 total combinations that we want to happen. Reducing this, it's 1 out of every 4 times we would expect to spin an odd number and flip tails, or 25% probability. Number 9, spinning a number greater than 5 and flipping heads. The numbers greater than 5 here are 6, 7, and 8. That's 3 possible combinations. So there's 3 favorable in the spinner out of a total of 9. Flipping a heads, again, that probability in itself is 1/2. But what about the compound probability between these two? Our total possible outcomes is 16 using the fundamental counting principle. That's what we found out. 8 times 2, 16 different combinations. How many of those combinations satisfy spinning greater than 5 and flipping a heads? The answer is 3. Are you noticing a trend here? There is a little trend. There's a pattern to compound probability and how we calculate it. Let's take a look again and see if we can see it. Taking a look at 7, 3 had a probability of 1/8. Heads had a probability of 1/2. Combined, we had a probability of 1/16. Number 8, our probability of spinning an odd number was 4/8. Our probability of spinning a tails was 1/2. Our compound probability was 1/4. And over at 9, we had 3/8 to spin a greater than 5 number, and then 1/2 to spin a heads. Compound probability became 3/16. The trend is this. The pattern is we take each event and its specific probability, and when we're dealing with compound events that are independent from each other, we're multiplying the two different probabilities. So 1/8 times 1/2, that's how we got 1/16. Now over here, 4/8 times 1/2 is 1/4. Make sure you reduce. You think you get it? Awesome. So that is how we do compound probability independently. Again, we're talking independent compound probability. Thanks for joining me.